Hi, welcome to Send to Print. You've probably seen this star fidget all over social media. It looks like a little magic trick, a star shape, a center handle, and somehow the whole thing slides around without falling apart. So how does it actually work? In this video, I'll explain how this print-in-place fidget can slide around freely without falling apart. The actual mechanism is quite clever, and the modeling is surprisingly simple. Then we'll take the same mechanism and turn it into something more playful. Let's start by looking at the mechanism. This is a print-in-place slider where each ring is printed as a separate moving piece. There are tiny gaps between the rings, so once the print is finished, they can move right away. From this angle, you can see it more clearly. Each ring is printed as a separate piece, so it is free to move, but the angled V-shaped profiles interlock with the neighboring rings, limiting the travel so the whole thing can move without coming apart. That's the trick. The parts are separate, but the shape keeps them captured together. Okay, now that we understand the idea, we can build it from scratch. Right-click the root component in the browser and create a new component. Let's call it Star Toy. First, we'll draw the outer profile. I'm using a 6-point star here, but the same logic works for 8 points, 12 points, or almost any star-like outline. Create a sketch on the XY plane. Press C for circle and draw a 100mm circle. Then add a second one at 75mm. These circles are just construction geometry to help us shape the star. Press L for the line tool and draw a vertical construction line from the center. Next, let's draw the first point of the star. Then add 2 more construction lines. Apply an equal constraint to these 2 edges. Then press D for dimension and set this angle to 60 degrees. Since we have 6 points, 360 divided by 6 gives us 60 degrees. If you want a 12-point star, this angle should be 30 degrees instead. Now we can use circular pattern to repeat this star point 6 times around the center. And now we have a complete 6-point star outline. Select the extra lines and hit X to toggle them to construction lines. That gives us a much cleaner profile to work with. Check if it is fully defined here, the small lock icon. Okay, finish the sketch and rename it to Star Profile. Next, we need the cross-section for the sliding rings. Create a new sketch on the XZ plane. First, press P to project this point. I'll hide the star profile for a moment and draw a rough profile. Make this line horizontal. Then use a midpoint constraint to align this edge with the projected point. Now press D and start adding dimensions. Set the thickness to 0.8 millimeters. For the height, I'll start with 5 millimeters and set this angle to 60 degrees. Now we have the top half of the cross-section. I'm using the mirror tool to copy these 3 edges to the bottom side. That gives us the cross-section for one sliding ring. Now select this line and hit X to make it a construction line. Next, we'll pattern it inward. Select all of the outer edges. Set distribution type to spacing. I'm using -2.5 millimeters. This value is a balance. Go too small, and you'll end up with too many rings and longer print times. Go too large, and the rings might slip right out. For the quantity, let's try 20 and see how it looks. That's too many. Let me change it to 16. Still too many. Let's go with 14. That looks about right. Hit OK. At the center, we need a solid core for the handle to attach to. Use the line tool to close that profile, then add the constraints needed to lock it in place. Now, everything looks fully defined. Okay, let's finish the sketch and rename it to Sliding Ring. Believe it or not, the hard part is mostly done. Go to Create and choose Sweep. Select all the profiles we just made. For the path, select the full outline of the 6-point star. To get a better look at the model, let's go to the Inspect menu and select Section Analysis. Pick the XZ plane as our reference. If you don't see anything, just click Flip. Now you can see that the rings aren't connected, but each one is trapped by the neighboring rings. Now, the only thing missing is the handle. Press E for Extrude and select the top face of the solid center core. extrude it upward by 50 millimeters. Set the operation to join. And that's the basic star fidget. You could print it right now or give it a quick polish. Select the top edges and add a small 1 millimeter chamfer. It looks great. This model and the Fusion 360F 3D source file are available on MakerWorld. You are welcome to download and check the source file. Through this file, you can clearly see every step of the modeling and the parameters I've used. Here is the print preview. You can see that from the very first layer, the rings are already separated, and they stay separated all the way up. If you want to print it in 2 colors, right-click at the layer where you want the color change and choose Change Filament. I would only change the top 2 or 3 layers of the star, so both colors show clearly, with only 1 filament change. Okay, send to print. Here's the final print. The best part is that there is no assembly. Once the print is finished, all the moving pieces are already printed in place and captured together. When removing it from the build plate, let it cool completely first, or gently flex the build plate so the model pops off more easily. Don't just yank it off. These rings are thin, flexible, and slightly springy, so if you pull too hard, you might pop a ring right out of its slot. After that, you can push the handle in different directions. The rings slide against each other, but the whole thing stays together. And honestly, I think the sound might be even more addictive than the look. Actually, I think if we keep the core structure, we can tell completely different stories with it. For example, what if the outer shape wasn't a star at all, but a set of water ripples? And the center doesn't have to be just a plain handle. It could be a little benchy sailing through the waves, or maybe a tiny frog sitting on ripples in the water. To give our little benchy more room to sail, I scaled the outer diameter up to 150 millimeters, swapped the sharp star points for soft wave curves, and placed the boat right in the center. It's the exact same mechanism, but with this new theme, the whole vibe completely changes. I absolutely love how the ripples look, but scaling things up triggered a brand new problem. When I pushed it like this, one of the ring edges could pop out pretty easily. The reason is simple. When the boat shifts to one side, all the rings slide with it. Because this larger version has way more rings, those tiny gaps accumulate. This creates a massive gap on the opposite side. If you keep it flat on a table, it's fine. But the moment you push it to the limit and lift it up, that accumulated gap gives the ring a perfect chance to escape. So for a larger version, the gaps between the rings need to be a bit smaller. That way the parts can still move, but they stay captured more securely and are much less likely to slip out from the edge. Here's the optimized version. The gaps between the rings are smaller, and that also gives us more water ripples. Now when I move it like this, it stays together. The trade-off is print time and material. To make it more stable, we add more rings, so it uses a little more filament and takes a little longer to print. Besides the benchy on water version, I also printed a frog version. You could take the same idea and turn it into a swimming duck, a melting ice cream cone, or go completely silly and make a very wobbly sunny-side-up egg. Okay, that's all for today. If you found this tutorial helpful, please hit the like button and subscribe for more 3D printing designs. Let me know in the comments what should I model next. Thanks for watching, and I'll see you in the next one.